Assalamu alaikum. This is Hassanul Banna. I welcome you to our 461 final project. Here we have built a line following robot and implemented PID controller. We used the robot that we used the last time. Only added 5 DS sensors to our robot so that it can detect our track. We also changed the floor color to white to make it easier for our robot to distinguish between the floor and the track. We created the 3D model of our track in Tinkerpad and imported that into Weavers. Our track has 6 left turns and 6 right turns. We also added some complex turns so that we can be 100% sure that our robot will work in all sorts of tracks. Now I will fast forward the video so that you can see our robot completing a whole round trip around the track. So as you can see that our robot has completed our round trip around the track successfully. So now my friend Ashfaq will talk about the sensor part.
My name is Ashfa. Here I will show you how we add the distance sensor. So we go to the robot section. In robot section, we go to its children. Here we add the distance sensor. In distance sensor, we, we change the value of translation and rotation and make sure that the distance sensor comes to the front side of our robot. And we also make sure that the x-axis of the distance sensor is facing the downward. Now we change the name of the distance sensor and we also give a type. Here we use infrared instead of generic. Now we will add 4 more distance sensor and do the same thing. Here we add total 5 distance sensor for this project. 2 on the right side, 2 on the left side and 1 is on the mid. Here we also change the name of the distance sensor so that we can use it on our code. Now my friend Ahad will talk about the controller code.
Assalamu alaikum. This is Muhammad Abdul Ahad. Now I will talk about the controller part. In the controller part, we have used the previous controller code and then added our the implementations of the LFR as well as PID. Here we have defined the variables, the names of the LFR distance sensors used for LFR, and then we have initiated or the enabled them here, and after that we have initiated PID variables here, and we have taken cap equals to 0.005, ki equals to 0, and cad equals to 0.15 after calibrating. And then we have taken the distance sensor values, and the leftmost one is this one and the rightmost one is R2, and then we have considered that if the distance sensor value is above 600, that means it's an error, and then we have compared with each of the distance sensors if they are in error range, and we have added the error weights, which is different for the different sensors, and it varies from leftmost -2 to from right to the rightmost weight of +2. And then we have also added if the distance sensor vector is in error range and counted them so that we can make an average error. So we have got the average error here, we here we have just made this count using the sum function of the errors, and then we have implemented PID here, the p equals to average error and I equals to I plus average error, and b equals to average error minus previous error, and the PID value equals to kp into p and ki in plus ki into I and kd into d, and previous error defined previous error equals to average error. And then if we have detected average error, then we have changed the speed of our robots so that it can uh, follow the path defined here. Thank you so much.